Hi, this is Chris Downs with IMTS TV. I'm here with John Riley, VP at Markforged. He's going to talk a little bit about his company and what makes it different. John, thank you for joining me today. Could you tell us who Markforged is?
Yeah, the simplest way to explain Markforged is to say we 3D print strong parts. And we do that across an incredibly wide range of materials, from composites to metals.
Can you tell me a little bit more about the composites? That's what makes you stand out, right?
Yeah, that's where we started. So one of the very first technology innovations that we did was figuring out how to wind a strand of continuous reinforcing fiber material through the inside of a plastic matrix. And what that unlocked was the ability to make a part that's as strong as aluminum in 2.5 axes, so you can actually start to replace aluminum in manufacturing applications. I have a prop here I'd like you to check out. I'll hold the mic. This part is just a standard plastic part, so go ahead and you can bend that. It's a brake lever for a motorcycle. You can see that it's very flexible. This is that same part, but it's been reinforced with that strand of continuous fiber. Go ahead, try and break it.
I'd say that's pretty strong.
Yeah, so what that's unlocked is a lot of manufacturing applications. So particularly at a show like this, when we're next to the tooling and the work holding section, we do a lot of jigs, jaws, tools, and fixtures. Applications where you need strength, but you'd also like to get your part quickly and have it be accurate and ready to go into your production system. And in many cases, we're lighter than existing solutions, so you can run your automation faster. So this example, right here is a set of gripper jaws that go on the end of a robot arm to move this coupling through the manufacturing process. That's a company called Dixon Valve and Coupling. Prior to using our composite printers, they used to machine these end effectors out of aluminum, and they cost about $280 a piece. After they bought a bunch of sample parts from a 3D printed service bureau. All of them broke except for ours, and they were able to put ours into the production line. They're $9.50 each. So they saved an incredible amount of money on each one, and they're able to have them ready to go off the printer in 8 hours, which just totally changes the world for them in the manufacturing environment, because now they can bring a line up faster if it goes down. They can design a new line in a shorter period of time, and their throughput increased because they're able to operate the robotic arms at a faster pace than they could before. So it's really game-changing for them, never minding the money they saved.
Right, that's fantastic. And I know you have some of those industrial composite printers here at IMTS, correct?
Yeah, that's right. So we're showing the X7 and the Mark II, which are the most popular of our printers. They're just the same technology, they're reinforcing with carbon fiber in a smaller and a larger form factor, depending on the size of parts you need.
Okay, and that's not all you have in your booth, right? I hear you have even more, some of the metal printers?
Yeah, we don't stop at composite parts for strong parts. We also print metal. We use a technology we call atom or atomic diffusion additive manufacturing. And how that works is you take metal powder and you bind it in plastic and wax, and you print that into the shape of your part. After it's printed, it's like metal injection molding material. You wash it in a wash that dissolves half the binder, and then you sinter it in a sintering furnace to get your final metal part. And so I've got an example here of a Stanley Black & Decker actuating housing that's been printed. This goes on the top of a hydraulic post hole pounder. And actually they were able to, so they have these machines in the field. They sell them for 50 years, and they need to service components when they break. And their choices before this were to machine them individually, to create a new manufacturing line to make them in small quantities when they came up for service, or to carry them in inventory. Now they're able to combine multiple units into a single one, save them a lot of costs, like 90% of their cost, and make it 50% as heavy. It's actually much lighter weight, which is nice when you're lifting something up to put it on posts. So there's a lot of advantages to being able to 3D print metals. We do it for a wide range of metals. Any metal that can be metal injection molded, we can print. Right now we have 17-4 stainless steel. We're introducing 316L, titanium, Inconel, pretty much you name it, we'll be able to do. And the entire end-to-end system to print these metals and wash and sinter them is $125,000 MSRP. So it's come down dramatically in price, making it accessible to many more people than metal printing ever has been before.
Awesome, so you guys have a lot of innovation here in the booth. Where do you see the future of manufacturing going, and how does Markforged fit into that future?
So it's end-use parts, right? And what we're doing is making strong parts that are capable of end use, and we're going to continue to push the areas and application spaces in which we make better sense to 3D print a part than it does to manufacture it through traditional means. And so over time, I think you'll watch us do larger and larger quantities of end-use parts and bite off more and more applications where strength actually matters.
Thank you so much for joining me today. If you'd like to learn more, be sure to visit the West Hall and visit the Markforged booth, or you can go to their website, markforged.com. This is Chris Downs with IMTS TV signing off.